Hello and welcome to Python for Engineers. Today we're going to be talking about pandas. Before I begin, I've already imported some data as a NumPy array, and if we look at that, it's just a 150 by 4-dimensional array. So we can do x.shape, we can do type, right? So not very exciting, incredibly useful. You should look at the lesson on NumPy for that, but we can get a little more functionality by using pandas. Pandas bills itself as an open source BSD licensed library, providing high performance, easy to use data structures and data analysis tools for the Python programming language. What that looks like is this. If we import pandas, and then it's common to import it as PD. So if you see PD in code, you might be referring to pandas. Data frame. And we can create a data frame just by giving it some data equals x. We can give it columns equals x label, and then labels, and there you have it. So if we look at just the first few entries, you can see that our data now have column labels. They also have indexes. So one of the most convenient features in pandas is the head function, which, as you can see, returns just the first 5 elements of the data frame. We can do df.head1 to get the first element. There's also df.tail, which returns the last 5 elements, and then df.tail, we can do 10 to get the last 10 elements, for example. We can do df.index, and that gives us the actual index of the data frame. Then we can do df.columns to get column names. So if I wanted to just look at a subset of columns, I could do something like this. Let's see, df at, I think we actually need it in 2 brackets there, sepal length. Boom. So there's the subset of columns, but that's again a little too big. So we can just do .head to that, and we just get the first few elements of the first 2 columns. And lastly, we can slice it by saying df.index mod 2. There we go. So we can make a little mask and just say df at there. And now we only get, every other element, but what that means is we can create a mask and index a pandas data frame with that mask. So, saying index equals 2 is not great, but maybe we can say df at sepal length less than, let's just say 6. And there you have it. Here's all of the here's all the entries in the data frame with a sepal length of less than 6. And that seems to be a lot of them, but there you have it. It's 83 entries. So a few other utilities available to you are df.describe, which gives you statistics. So it gives you statistics for each column, so that's kind of nice. Tells you how many entries there are, tells you the mean, the standard deviation, the min, the max, and the percentiles. Obviously very useful. We can also do df.t to get the transpose. This is not immediately useful, but it does really help when you're trying to shape your data, or maybe you're reading data from a different source. And as you can see, we now have the transpose because df.t.columns returns 0 through 150. df.t.index returns the column, or it returns the names of the measurements, and that was the original column name, so now it's transposed, so it's the index. Lastly, you can sort a data frame. So if we have our data frame here, we have an unsorted column by sepal length, right? 5.1, 4.9, yada yada. We can do df dot sort values and by equals cm. And there you have it. Now the data are in increasing order by sepal length. So given our data frame, we can do some more complicated slicing using df.loc. And what's neat about LOC is we can give it basically both coordinates, right? The index and the column name. So we can do, let's say, 110 by 120, and that'll give us 110 to 20. And then we can also give it column names. And I'm going to be lazy here and just say df.columns at 0. And that'll give us the first one, 0 through 2. It'll give us the first 2 columns. And let's be a little more exciting here and say that. Now we have all but the 0th column. So given our data frame consisting of 4 columns and 150 entries, we can add a new column, df, just by indicating what we want it to be called, df new column. Let's set equal to, that's just np.random.rand for x blank in range length df. This will error out because I don't have numpy imported. So let's import numpy as np and try that again. And now we do df.head. As you can see, we have this new column available to us. Oops. Let's try zooming out here. It's not working. Great. That's fine. So we have the new column, df.columns, new column. So creating new columns is as simple as that. In addition to fancy indexing and column operations, we can also do some SQL-like joins. So let's go ahead and make some new data for that, data frame. This time we're going to use a dictionary. And let's make the right data frame. Three, 4. We can do pd.merge left and right. And there you have it. Nice simple join. Let's go ahead and create a new column. Recall, we have our 4-column data frame with sepal length width and petal length and width. We also have y equals iris targets. Is that right? Yeah, dot target. And that's just a list of labels. Not very exciting because it's 0 through 2, but we can do the following. And let's see if we say iris dot target names at p or p and iris dot target. There we go. Now we have the actual target names of the particular species that was measured. So then we can just say df at label is equal to this list of target names. And if we look at df.head, you can see the labels exist. Now that's kind of useful, especially if we want to run some statistics. Obviously we can use df.describe to get counts and means and stuff, but if we want to do something a little more advanced, we can use the group by feature. Dot group by equals. Okay, so that's fine. But we can just ask for the sum. We can get the sum of sepal length, not very exciting, but we can also get the mean. We can get the median sepal length, or we can get the median measurement per label or per species. Let's see what other features are available. Yeah, we can get the standard deviation. Let's try this. df dot. So yeah, we have we can do apply, backfill, correlate. Ooh, we can do a count. Just say, boom, should be 50 in each, right? So now we know we have 50 of each species. This is one of the reasons I like using IDEs like Spider, because it's got this function suggester, and it's just nice and useful. We can do cumulative sum, not very exciting. Cumulative sum is useful though in other situations, so keep that in the back of your head. Describe difference, d-types expanding, groups. There we go. So, we can get the largest length and width per species. So yeah, that's group by. It's a very useful little tool. If you ever need to create pivot tables, you'll want to use the group by feature. So I want to close this session out by working through a notebook I wrote on working with missing data.